So here's some examples on how to find oxidation numbers. Okay, um, yeah, we'll just go through these. If you have any questions, feel free to email me or comment on the video. Okay, so determine the oxidation number of carbon for the following compounds. So again, if we're looking back at the table that we have, okay, from our notes earlier, we kind of have this table beside us. Okay, it's helpful. So like, and we just go through, like, look through, does it have this? Does it have this? And go from there. Okay, so the first one, we have carbon and hydrogen. So we're going to start with assigning hydrogen as a +1. Okay, once we have that, we know it has overall charge of 0 for this. So +1 times 4 is 4. So carbon's going to have a -4 charge. Over here, again, we start, our hydrogens are all going to be +1. Next, we can assign all of our oxygen as -2. Okay, and now we're just using algebra. So again, we have +4, -2. So we need two more negatives to kind of balance this out. So our carbon's going to be -2. For this one here, again, +1, -2. So in this case, we have +2, -2. So the actual oxidation number on carbon is going to be 0, okay, which is fine. You can even get fractions. That's fine too. Okay, like you're just whatever it works out to algebraically, that's the number you're going to put in there. Okay, for this one, hydrogen's +1, oxygens are -2. So we have -4 +2. So we need a +2 charge on carbon. Okay, so that's how I'd solve for those oxidation numbers. Continuing down here, now we're going to use in the next rule. So we're looking for like monatomic ions, things like that. Or like in this case, if we look on our sheet, we should do it says most halogens are -1 unless they're with something that's more electronegative. So in this case, iodine's -1. We have two of them, so we get a -2. So that means magnesium has to be +2 to balance that out. Any element on its own, again, it doesn't matter how many there are, it's just one thing, it's 0. Okay, for this one, we have a charge of -1, so make sure you don't forget about that. We label oxygen first as -2. There's 3 of them, so that's -6, meaning to get an overall -1 charge, we need 5 chlorines. For water, oxygen's -2, and then hydrogen's +1, so that balances each other out. For sulfuric acid here, our oxygen is +1, or hydrogen's +1, oxygen's -2. So -2 times 4 is -8, +2 is -6. So we need +6 to balance that out. Last two examples here. Okay, so we have hydrogen. Okay, again, it's +1. We have 2 of them. For this one, hydrogen's with the metal, so it's actually going to be -1. Because it's a hydride, this would be calcium hydride if we were to name it. Okay, and then, so that would be -2, so making calcium +2. Okay, this one's a little bit tougher, so we have 2 polyatomic ions. Okay, well, again, we just start with what we know. We know that oxygen has to be -2, hydrogen has to be +1. Okay, again, like if we're looking at these two as far as electronegativity, we also know nitrogen's more electronegative, and so we're going to write down its charge too of -3. Okay, now we can balance it all out. So we have a +8 charge because 4 times 2 is 8 times 1, and then a -6 charge. Okay, we have another -6, we have -12 and +8, meaning we have an overall charge right now of -4. To balance that out, this is going to have to be +4. Okay, another way to do that one is like if you split into its two polyatomic ions. Okay, and then you can kind of solve for like what would their charges be. If this is +1, and we have to end up with the overall +1 charge, this is going to be -3. Over here, this is -2, which is -8. Or sorry, I wrote this down. It should be SO3. So we got a -6 charge. We need to end up with a +2, so that's going to be +4. Okay, so just a different way to do it. All right, those are some examples to hopefully help you with your assignment. Okay, and we'll go from there.